Hello, good morning friends. Last we see the dimensional formula. Now we see example about it. Example 2.15. Let us consider an equation 1 half mv square is equal to mgh, where m is the mass of the body, v its velocity, g is acceleration due to the gravity, and h is height. Check whether the equation is dimensionally correct or not. In this method, you have to check the dimension of left hand side, then right hand side, and compare it. First, dimension of the left hand side, 1 half. 1 half have no dimension, so only consider about mv square. First, the dimension of mass into dimension of velocity square. Dimension of mass is what? m1, l0, t0. Now the dimension of velocity is m0, l1, t minus 1 square. So m1, l0, t0. Here m0, l2, t raised to minus 2. Now simplifying m1, l2, t minus 2 equation number 1. Now the right hand side. There is a dimension of mass, gravity, acceleration, and height. Dimension of mass is m1. Now gravity, acceleration is l1, t minus 2, and height is l1. Simplifying m1, l1 plus 1, l2, t minus 2, equation 2. From equation 1 and 2, we see LHS is equal to RHS. Dimension of the both the sides are same. Dimension of M, L and T are exactly the same with sign. So LHS is equal to right hand side RHS. So this equation is dimensionally correct. Not say all time correct, but only dimensionally correct. Now we see the example 2.16. The SI unit of energy is joule is equal to kilogram meter square per second raised to 2. That of speed V is a meter per second and acceleration is meter per second square. Which of the formula for kinetic energy K given below can you rule out on the basis of the dimensional argument? M stands for the mass of the body. A is what? K is equal to m square v cube. We check the dimension. Left hand side, only kinetic energy. Dimension of any types of energy, we have m1, l2, t minus 2. Now the right hand side, square of mass, cube of velocity. So dimension of mass is m1, its square, so m2. Dimension of velocity is l1, t minus 1, it cube. So m2, l3, t minus 3, equation 2, this is equation 1. From equation 1 and 2, LHS is not equal to RHS. So this formula, this equation is dimensionally incorrect, you can say that. Now the B. B, K is equal to 1 half mv square. So this is a K kinetic energy 1 half mv square we have here, m1 l2 t minus 2. So from this we can say this is dimensionally correct. This is not dimensionally correct, but this is dimensionally correct. Now C. K is equal to mm. In all A, B, C, D, E left hand side is only kinetic energy. So all ABCD dimension of left hand side is m1 L2 T minus 2. In A, right hand side wrong, B right hand side same, C right hand side ma. We know m into a mass into acceleration, it is a force, not an energy. So this is also dimensionally incorrect, but check it. Left hand side same, so right hand side. Dimension of mass, dimension of acceleration. Mass is m1, acceleration is L1 T minus 2. So compare with equation 1, it's not a correct. Now the D. D is what? K is equal to 3 by 16 mv square. So mv square, dimensional of mv square is same as the energy m1 L2 T minus 2. Here kinetic energy. So dimensionally correct, but formula is wrong because kinetic energy is 1/2 mv square. So this is dimensionally correct, but actually this formula is wrong. But we have here compare only dimensionally, so that's true. Dimensionally correct. This is also dimensionally correct. Now the E. Kinetic energy K is equal to 1/2 mv square plus ma. Right hand side there is a two step. This is same dimension as left hand side, but this is not. Dimension of these two steps are wrong, so you can't sum of these two because dimension of this is force and this is energy. You can't sum energy with the force. So this right hand side is wrong. So don't compare with left hand side. Not comparing left hand side because the right hand side is wrong. These two steps have a same dimension, then you can sum. But here these two steps have a not a same dimension. So this is false, so you don't compare with this. Okay. See you next.